Life. Earth is full of it, from the oceans to the skies, mountain ranges to river valleys, scorching deserts to steamy jungles. Everywhere we look, our planet is literally crawling with billions of living creatures. So why haven't we seen evidence of life anywhere else? Beyond the Earth, we have not found a single sign of extraterrestrial life anywhere else in the universe. Not one. We visited almost all the planets in our solar system and even sampled asteroids and visiting comets to check for living organisms like us, but so far, all we can do is wonder if there really is anything else out there. But scientists are absolutely convinced that there is life beyond Earth. In fact, many people believe that it's not a matter of if we'll ever encounter life outside of our world, but when. And when we do, what can we expect to find? Join us as we explore the countless possibilities of what secrets of life the universe may hold for us, from vibrant, colorful worlds like ours, supporting a diverse mix of species, to intelligent entities existing on a level we cannot comprehend. We can only imagine what is living out there among the stars. Believe it or not, there is a very big possibility that we're not the only living creatures in the universe. While the Earth may seem to be a one-of-a-kind oasis for life, the sheer number of other planets we know orbit different stars means there is a much bigger chance of there being other forms of life in the universe than there isn't. It's simple mathematics. And the numbers support the theory. Let's take a look. The Earth orbits inside the habitable zone around the Sun, a region of space near a star where temperatures allow liquid water to exist on the surface. As we all know, on Earth at least, water is essential for life to exist. If a planet sits too far from its star outside of the habitable zone, the water freezes, locking it up in ice sheets. Too close to a star and water evaporates, swirling around the atmosphere in gaseous form. Along with a few other requirements such as stable atmosphere and the presence of oxygen, any planet orbiting within the habitable zone of its star is capable of supporting life. Our solar system has 8 planets, 4 rocky worlds, and 4 gas giants. Of these 8 planets, only 2 of them orbit inside the habitable zone, Earth and Mars. And some people argue that Mars is, in fact, too far outside of it to support life. But for the sake of experiment, let's assume that Mars can, in fact, support some form of life by itself. That means that of the 2 planets orbiting inside the Sun's habitable zone, 1 has life on it. That's a 50% success rate. Now, it is estimated that our galaxy, the Milky Way, is home to between 100 billion and 400 billion stars, along with our own. Let's take the low end of that estimate, 100 billion. Of those 100 billion stars in the Milky Way, there is estimated to be at least 1 exoplanet, the name scientists have given to planets outside of our solar system, on average orbiting each of them, and our solar system has 8. Around 7%, or 7 billion, of our galaxy's stars are G-type stars, similar in size, composition, and age to our own Sun, most of them emitting around the same amount of light and heat. Scientists believe, based on observations, that at least 1 in 5 of these G-type stars have an Earth-sized exoplanet orbiting somewhere inside their habitable zones. That means that in our galaxy alone, there are at least 1.4 billion rocky planets similar in size to the Earth orbiting stars like our own inside a region where liquid water can exist. If even 0.1% of those planets, not to mention the countless moons out there too, held some form of life, and we applied our own solar system success rate, there would be no less than 700,000 places in our very own galaxy that are potentially home to extraterrestrial life. And here's one last number for you. There are an estimated 125 billion other galaxies in the universe. It's pretty clear that the odds are heavily stacked in favor of there being life out there. So, where is everyone? Why does it seem that we are, in fact, alone if there are so many opportunities for life to exist beyond Earth? For one thing, space is incredibly big. The distances between stars alone means that the chances of two interstellar species encountering one another, whether through space travel or by accident, are virtually zero. For now. But as technology on Earth advances and we move closer to interstellar travel, it's only a matter of time before we get the chance to visit these planets to see for ourselves. Until then, we can only speculate what life beyond Earth looks like. And if these exoplanets are capable of supporting even a fraction of the diversity of life that Earth can, the possibilities are endless. For generations, people have been coming up with weird and wonderful theories about what life on other planets might look like. Discovery Channel's Alien Planet explored some of these possibilities, and Netflix's Alien Worlds has given us an even closer look at what opportunities exist for different alien species. But without any specimens or evidence to go by, it is simply impossible to predict or even comprehend what life beyond Earth may look like. We can, however, base some of our assumptions on life on Earth. After all, if life emerged here the way it did with such success, and has survived for well over 3 billion years, it is entirely possible that life beyond our planet may follow the same basic rules. Life follows a simple chemical recipe. All you need are some critical elements and the right conditions. Nitrogen, hydrogen, oxygen, water, and carbon form the building blocks of life. As it turns out, these elements are widespread throughout the universe, existing in gas, liquid, and solid states in stars and nebulas, on rocky planets and gas giants, and even in asteroids. Once you add the proper ambient temperature, between 0 and 100 degrees Celsius, a stable, breathable atmosphere, and the right amount of water and oxygen, you have everything you need for life to spark into existence. However, life also requires a few more things to thrive. Energy, for example, to sustain it, a means to reproduce, and a place to live. Here, things get interesting, as these components can come in many different extremes on the diverse worlds capable of hosting life beyond Earth. If there is life out there, how it looks and lives can really all depend on what type of world is hosting that life. Besides the rocky planets like our own and the gas giants orbiting our own star, we're not 100% sure what other worlds even look like. While we are able to see how close to their stars they orbit, or whether they're inside their habitable zone or not, estimate their size, and even work out how old they are, only by traveling there will we know for sure. For now, we can only use the limited information we have gained by looking at these exoplanets from billions of kilometers away to make a best guess about the conditions on these different worlds. While some planets may be home to thousands of diverse species with the conditions perfect for life to thrive, others may support only one or two different life forms that dominate it. Perhaps we'll find a predator-prey ecosystem, or maybe organisms that live in perfect harmony, having evolved into a symbiotic partner species. Life may exist in its earliest, simplest form, similar to how the Earth looked when it first appeared here, or have advanced into highly intelligent, space-faring species who have been the ones watching us evolve all along. Who knows? What we do know is that it is very probable that life on other worlds will have adapted to suit the environment on the surface. Much like our own solar system, these environmental conditions can vary greatly. Take Venus and Mars, for example. While both lie on the edge of the habitable zone around our Sun, their surface conditions are very different from each other. Venus is boiling hot, with 300 km/h winds blasting a volatile mixture of sulfuric acid rain and 500 degrees Celsius carbon dioxide at 90 times the atmospheric pressure of Earth. Mars, on the other hand, is quieter and colder, much colder. The red planet's atmosphere is only 1% that of Earth's. This means that the sun's heat escapes the planet quickly, leaving temperatures to drop to as low as 120 degrees below zero. Now, if life did ever exist or one day evolved on both planets, the creatures that stalked the surfaces would look very different to one another. The same goes for the diversity of the universe. If there is life out there, it most probably boasts incredible variety. There are other planetary conditions beyond chemistry, pressure, and temperature that would affect how life would evolve beyond Earth. Take gravity, for instance. On a bigger or denser planet with more mass, the gravity would be higher, meaning that life would need to evolve to be shorter, stockier, and perhaps even with multiple limbs for additional support. On a smaller planet with weaker gravity, however, life could hop, jump, and glide far more easily and would be more likely to evolve lighter, taller bodies than creatures on a high-gravity planet. The pressure density and chemical composition of the atmospheres would also affect how easy it is for life to take to the skies. Denser air means that life forms could take advantage of the extra friction created by the high pressures. This would allow some life forms to treat the sky like an ocean of air, where they can swim in the dense gases, getting from point A to B with ease. Oxygen-rich air would fuel more energetic creatures, while limited air could mean that organisms are far smaller and much less active, allowing them to conserve precious resources. The seasons on planets could be very different too. Some planets have much shorter or longer orbital periods than what we're used to on Earth's. In fact, some planets have seasons that last for an entire year from their perspective, or even have years shorter than days. While some worlds may spin on a perfectly aligned axis, virtually eliminating seasonal changes, others may tilt dramatically, bringing extreme differences in temperature and conditions as the seasons change. And some planets may follow a very elliptical orbit around their stars, bringing short, boiling hot summers and long, dark, frozen winters. So, with all these possible scenarios of temperature, gravity, pressure, chemistry, and energy to consider, how much do we know about what life beyond Earth might actually look like? Well, with so many different possibilities to consider, not much. However, because we have our own life on Earth and a track record of its evolutionary progress, if we follow the same rules of physics and biology of nature, we can make some educated assumptions about other worlds. Plants, for example, may be nothing like the trees and flora we know at home. On other worlds, plant species may have found ways to move around, constantly searching for better soil and water to sink their roots into, and for areas with more light to soak up. They may not even need the energy provided by their own star to photosynthesize, relying on hunting for food by eating other plants or trapping unsuspecting bird-like creatures like a massive Venus flytrap. Worlds with a very low density and thus low gravity and an oxygen-rich environment may boast life similar to how Earth looked during the age of the dinosaurs, only much bigger. Without gravity holding them down and vast spaces to live in, creatures could easily evolve into massive beasts, hundreds of feet tall and weighing tens of thousands of tons. Nourished by lots of O2 and food, these mega creatures would be an impressive, if not scary, sight. At the other end of the spectrum, animals and plants may be forced to compete on a world where every molecule is in high demand. Low oxygen or low pressure atmospheres would mean that life forms would need to find ways to optimize their oxygen intake, leading sluggish lives in an effort to get the most out of the limited air. Flying creatures in this world would never land on the surface because the lack of air resistance would make taking off again impossible. Some worlds may be too far away from their star to get enough light and heat. There are creatures living out existences on cold, frozen planets. Here, life would have to find innovative ways to capture even tiny amounts of energy they need to survive. Organisms on these worlds may be forced to rely on chemosynthesis, converting carbon into energy, or on heat escaping from the planet itself to stay alive. Scientists have long suggested that there may be vast liquid water oceans below the icy surface of one of Jupiter's moons, Europa. The planet's geothermal activity, generated by its changing proximity to Jupiter, is believed to create enough heat to maintain these liquid oceans, and possibly even life. Creatures living on dark worlds may never need to evolve eyes, or those on planets with extremely bright stars may have found ways to exist deep below the surface to escape the heat and brightness above. Ultimately, however, the big question still remains. Is there any intelligent life like us out there? Well, the odds point towards us finding basic, simple life on another planet before we'd likely discover an advanced, sentient civilization. But that doesn't mean intelligent beings aren't out there waiting to meet us. Scientists hope that within our lifetimes we'll finally discover the first evidence of life beyond Earth on one of our neighboring planets. Although it will probably turn out to be fossilized single-cell organisms unearthed on Mars or simple microbes spotted in the depths of Europa's seas, finding out that the Earth is not the only place in the galaxy or the universe capable of supporting life will be our single greatest discovery. This will no doubt lead to humankind accelerating our space exploration programs in the hope of finding even more life among the stars, heralding a new chapter in our history. We're only a few years away from returning to the moon and hopefully less than a decade from putting people on Mars, events that may just answer some of the questions about life beyond Earth. It's no longer a matter of if there is life beyond Earth, but where and when we'll find it. Remember to like this video and subscribe to the channel. We've got lots more videos like this coming, so keep on supporting us and we'll keep bringing you awesome content just like this.